Go. So this is section 4, 6. Again, I'm going to try to get all through the notes. Crossing my fingers on that one. Now, it seems weird that we're jumping all the way back to chapter 4 to pick up a section for chapter 11. And the reason we're doing that is because this material comes up on the test all the time. So we wait until chapter 11 because it's very similar to one of the sections in chapter 11. We wait until chapter 11 so that it's fresh in your brains when we get to the test. We get to the end of course test for Algebra 1, which again is in 2 weeks, right? So it's called arithmetic sequences. Arithmetic sequences. Now, we're going to start off the day by talking about this example. During a thunderstorm, you can estimate your distance from a lightning strike by counting the number of seconds from the time you see the lightning. You guys ever do that? It flashes, you can count, and based on the number of seconds, you can tell how far the storm is away. Like you can tell how far the lightning strike is away. When you list the times and distances in order, each list forms a sequence. Because you can, calculate, okay, if it's 3 seconds away, it's this distance. If 4 seconds away, it would be this distance. 5 seconds away, it would be this distance, right? We can calculate, we can have a table of values, and what that table of values is really called is a sequence. If you just look at the y values, you can call that what's called a sequence. Now, sequences have patterns. Just like equations have patterns, you can say, how does the x value relate to the y value? And you can create a pattern based off of that. A sequence has patterns as well. By definition, a sequence is a list of numbers that often forms a pattern. Each number in a sequence, each place in a sequence, is called the term of that sequence. So take a look at the table here. What is the pattern that you see within that sequence? What? Don't just say 0.2. What's happening?
The y value is going up 0.2.
Good. If I look at my x values, they're constantly spaced, right? 1, 2, 3, 4, 5, 6, 7, and 8, right? Evenly spaced x values. And the y values, the second values, they're going up by a value of 0.2. And we're adding 0.2, correct? Are we multiplying by anything? No. That will come into play tomorrow. We are adding each y value by 0.2, exactly 0.2. This is what's called an arithmetic sequence. Notice that in the distance sequence, you can find the next term by adding 0.2. And you could keep that pattern going, right? You could continue that pattern and say, okay, if it was 15 seconds, I could just keep adding 0.2. If it was 100 seconds, I could keep adding 0.2. But what if it was like 1,000 seconds? Could we keep going with that pattern? Yeah. But would it get pretty labor intensive? Yes. And then we're thinking, okay, well, maybe we can create some sort of equation to model this situation. This is what's called an arithmetic sequence. An arithmetic sequence is one that goes up by constantly adding the same value forever and ever. Adding, not multiplying, adding. I could say subtracting, but remember that subtracting is just adding a negative. But the constant difference that we have is called our d value. You're going to hear me refer to something as the d value. That's our constant difference. That's the thing that keeps continually getting added or subtracted. Okay? So my common difference above would have been 0.2. Okay? Remember the 3 dots on the end of a sequence, just remember that means that pattern will keep repeating forever and ever, infinite. So let's take a look here. Determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference and then the next 3 terms. So let's do this. Is this an arithmetic sequence? Can I call this an arithmetic sequence? What do you notice the difference is? What's the difference? 4. Is that constant throughout? And are we adding 4 each time? Yes, so we can call this an arithmetic sequence. We see that this is plus 4, plus 4, plus 4, and it looks like that pattern will continue. So we can say that it is arithmetic. It says, if so, find the common difference. We're going to say that the common difference, we're going to call that our d value, is 4, a positive 4. Then it says to find the next 3 terms in the sequence. So what would come after 21? And then? Pretty simple, right? I guarantee there are going to be questions that look exactly like that on the air test. Maybe it might say like, okay, which of these sequences are arithmetic? You might see a term, which of these sequences are geometric? We'll talk about that tomorrow. That's section 11.1. Let's do it again. 10, 8, 5, 1. Is that arithmetic? No. Do I see some sort of pattern? Yeah, because I go down 2, I go down 3, I go down 4. But it's not arithmetic because there's not a constant change. So we can just say that this is not arithmetic. Because I see a down 2, a down 3, a down 4. That's not arithmetic. Okay, now be careful with these fractions. Don't these all have a denominator of 4? So really, I'm just looking at the numerators. How much is my numerator changing? Thank you. 2/4. I'm going up by 2/4, right? My numerator is changing by 2. Up 2, right? Going from -3 to -1. I'm going up 2. So I just put the denominator 2/4. Yeah, I know that's 1/2. Going from -1 to +1, what did I do? 2/4. Going from +1 to +3. 2/4. Okay, so is this arithmetic? Yes. What's my constant difference? 2/4, and at this point I can simplify it down to 1/2. Okay, I've got 3/4. What's my next term? Keep adding 2/4. 5/4, then. Okay, so it's just a pattern, right? That's all we're seeing here. It's a pattern where it's repeatedly adding. Okay, how much am I going down here? Going from 2/3 to 1/3. I'm going down 1/3. Did that pattern continue? No, I jumped down 2/3, right? So is this is not arithmetic. There's not a constant change. Yeah.
Wouldn't people call this arithmetic? Like some people call this arithmetic.
Yeah, it's spelled the same way. Arithmetic. Okay. When you're referring to a sequence, you call it arithmetic, but you're right, it's the same way. It's like what are other words like that? Words that spell the same way, but are said differently. Homophone? Is that what I call it? Yeah, homophone. All right. 4 to 1, 1 to -2, -2 to -5. What's my pattern? Down 3, -3. Down 3, down 3, down 3. And that's constant throughout, so we can call this arithmetic. What's my D value? -3. My next 3 terms? Pretty easy to tell, right? That's just the next 3 terms. But the problem is, what if I had said, okay, this is term 1, 2, 3, 4, 5, and 6. What about my 100th term? Would you really go on and list 100 terms? I hope not. I hope we would try to find some sort of equation to model this. The variable a is often used to represent terms in a sequence, so you can read a and then a little subscript 9 as a sub 9. That is the 9th term in the sequence. So if I really truly asked you, what is the 100th term? The notation for that would be saying, okay, what is this equal to? Right? That's what I'm asking you. So if you ever see that notation and it asks you, okay, what's a little 50? They're asking for the 50th term in that sequence. That's what they're asking for. Okay, so to designate any term, the nth term of the sequence, you write a sub n, where this will give you any term. We make that term arbitrary, and we say, okay, what if we want the 100th term, or the 1,000th term, or the 15th term, whatever, where n can be any number. So what we say here is you can create an equation with any arithmetic sequence as follows. You start with your first term, and then you repeatedly add on common differences, right? You always start with your first term, and you say, okay, there's my beginning value, right? There's my beginning value. There's my starting value. Then I take, cycles of my difference, right? I could add, if my common difference was 2, I could keep adding 2 over and over and over again. How many times? Well, it depends. I need to add it on a certain amount of times. How do we get that number? Well, if I want the second term, I'm going to add that on 1 time. If I want my third term, I'm going to add it on 2 times. I want my fourth term, I'm going to add that on 3 times. What's the pattern there? 1 minus the amount of term. So if I want my 100th term, I'm going to take my starting value plus 99 more times of my difference. What's the formula for that? The formula is A1 plus n minus 1 times D. Guys, they are not going to give you that formula on the air test. That's one formula that you definitely need to know. That is one formula that you definitely need to know. This is the arithmetic sequence term, or formula. A sub n, that's how we read that, A sub n, finding the nth term in the sequence, is A sub 1, your starting value, plus your common difference times n minus 1. So if I'm looking for the 100th term, I take the first term plus 99 times my difference. If I'm looking for my 1,000th term, I take my first term plus 999 times my difference. And then that will give you that term in the sequence. Okay, so let's practice that. Let's identify each piece here. What's A sub 1? 4. That's an A there. Looks a little weird. A sub 1 is 4. Because my formula, let's start by this. A sub n is equal to A1 plus n minus 1 times D. All right, so what I'm looking for here is I want A sub 16, right? I want A sub 16. That's what this is asking for. How do we know 16? Because I'm looking for the 16th term. A sub 1 is 4. What is n again? What term am I looking for? 16. N is 16. N is always the number of term you're looking for. So it's 16 minus 1. I realize that's 15, but I'll do that in a second. And then D. Now, what is D in this arithmetic sequence?
4.
4. 4 to 8, 8 to 12, 12 to 16. D is 4. That's where I get my D is 4, my common difference. All right, so that means that A sub 16 is 4 plus 15 times 4. So I go to my calculator and I say 4 plus 15 times 4. 64. The 16th term in this sequence, I should write that a little clearer. Little 16 is 64. Yeah, if you go through, so if this is term 1, and you start listing them out, and you keep going all the way up to 16, it'll be 64. Let's do another one. Let's find the 25th term in this sequence. Now, I'm not even giving you what the sequence is, but we're given enough information to find the 25th term. Remember, the formula is A sub n is equal to little a sub 1 plus n minus 1 in parentheses times D. All right, so I'm looking for A sub 25, right? That's the term I'm looking for. What's my A1? That good steak sauce. You ever dip fries in steak sauce? Like dip fries in A1?
Oh, it's so good.
Oh my gosh, that's
Or
so
mashed
good.
potatoes.
Put A1 on mashed potato. Ooh, I've never tried that. Yeah, I have put it on. Like, you get a steak and then you just like soak it up. Oh, yeah. Well,
A1 is -5.
thank you. And then n minus 1. We're looking for 25 minus 1. If you want to go ahead and just write that as 24. Okay. And then my d value is -2. Now, that means that this sequence is decreasing, right? This sequence is going down because my d value is negative. All right, so let's figure out what it is. A sub 25, I'm going to clean it up a little bit. -5 plus 24 times -2. So let's go in my calculator and do that. -5 plus 24 times -2, and that will give me -53. A sub 25 is -53. If I run my numbers, if I start with -5 and I continually decrease by 2, I will get to -53 by the time I reach the 25th term. Let's do that again. Let's find the 60th term. See, now this becomes a little bit more, labor intensive. I mean, 25th term, you could have done that. Wouldn't have taken you too long. But 60 terms, especially when, what's my difference? What's my difference here? -6. That's kind of hard to count by sixes. So my D is -6. What's my N that I'm looking for here? 60. I'm looking for the 60th term. And my A sub 1, what is that? What's A sub 1? 11. My starting term. So I'm going to say, remember my formula is A sub N is equal to A sub 1 plus N minus 1 times D. So A sub 60 is equal to 11 plus, okay, I'll do it in my head here. 60 minus 1 is 59 times D times -6. Again, the negative value on the D is meaning that this is decreasing. So I go ahead and I plug that in. I say 11 plus 59 times -6, and that's going to get me -343. Do you think you could have gotten that? I guarantee there will be a question that says, here's the sequence. What's the something term? The problem is remembering the formula. Let's do that one more time. I want the 12th term. So N is 12. A sub 1 is 4.2. D is 1.4. And I'm looking for A sub 12. So that means A sub 1, 4.2, plus N minus 1. 12 minus 1 is 11. Times D, which is 1.4. See, now, why are we studying this now? Well, we're studying this. Why was this in chapter 4? Let me say that. Well, because this is a constant change of value. A constant change is a linear equation. See, if I'm continually adding on to my y values, that's really just like a straight line function. So that's why it was included within chapter 4. So this is 19.6. That's why this was included within chapter 4, because chapter 4 was all about linear equations, straight line functions. All right, let's take a look at one word problem here. A bag of cat food weighs 18 pounds. Each day the cats are fed half a pound. How much does this bag of cat food weigh in 30 days? Do you see how this represents an arithmetic sequence? I'm continually decreasing the amount. I'm continually subtracting the amount. So what's A sub 1? My starting value is 18. What's my D? I'm subtracting, so it's -0.5. And then my N value is what? 30. So I can say A sub 30 is 18 plus 29, 30 minus 1, 29 times -0.5. So 18 plus 29 times negative 0.5, that's going to give me 3.5 pounds at the end of 30 days. Okay, we won't do the last one. But that's what we can see here. An arithmetic sequence is continually subtracting or adding. What we're going to talk about tomorrow is something called a geometric sequence. See, it's a pretty easy thing to learn, right?